In this video I'm going to do problem number 20 from homework 3. This is from chapter 5. This has to do with the lottery and the way to count correctly. So we're going to use combinations, and let's look at the question. The question says, in the Minnesota North Star cash drawing, you pick 5 different numbers between 1 and 29. What is the probability of picking the winning combination? Order does not matter. Okay, so what are we going to do? We're going to pick 5 numbers from 1 to 29, and we don't have to get them in the right order. So what we're going to, the way to think of this is we're going to say, how many choices do I have for the first number, second, third, fourth, and fifth? So I'd say I've got 29 choices for the first one. Once I pick that one, I can't choose it again. And then I've got 28 for the second, 27, 26, 25. And one way to think of what's going on here is you could say, well, how many ways can I arrange all of these numbers? 24, 23, and so forth, all the way down to 2 and 1. But I don't care about these 24 over here. So I'm going to divide this total number, which is 29 factorial, by the number of ways that I can rearrange the 24 down here that I don't pick, which is I've got 24 choices for the first one, 23 for the second one, and so forth all the way down here. So what we've got so far is 29 factorial divided by 24 factorial, and that would tell us the number of permutations of these 5 numbers that we pick, and that would suggest that we needed to know what the order is, but according to the lottery we don't need to know what the order is. So what I've really done is I've said, how many ways can I divide these numbers, 29 numbers, into 2, but I don't care about the order of either of the divisions. So you could think of this as 29 choose 5. So there's 5 ways I can put the first of the numbers that's chosen, 4, 3, 2, and 1. So we get 5 factorial in the denominator here. So this is just 29 choose 5, and it turns out to be the same thing as 29 choose 24. So if you want to really think about what's going on, you could say, how many ways could I choose 24 of the numbers, and what's the probability of doing that? And what turns out to be the same as choosing 5 of the numbers. So the question that we're being asked is, what's the probability of choosing, or probability of winning? And that's going to turn out to be 1 divided by this number. So 1 divided by 29 choose 5. So that's going to be 5 factorial times 24 factorial over 29 factorial. Incidentally, I can use Excel, the function combine, C-O-M-B-I-N, combin, actually, 29 comma 5 to get this number. So what we're looking at here is 1 over combine 29 comma 5. And so let's go over to Excel and try this out. This is going to be equal to 1 divided by, well, I'll do the combine 29 comma 5. We'll do that first. So how many different numbers are there? There's 118,755 possible tickets or combinations, and so we're going to take 1 divided by that number, and that's going to be the answer that we're looking for. And so I'm just going to copy that and go over to Connect, and I'm just going to paste it directly in there. So Control C is copy, Control V is paste. They want it to 6 decimal places, but I'm going to put it in as just as it comes out of Excel, with 8.4 times 8.4207. The E negative 0.06 means 10 to the minus 6. And so when I click check my work, it accepts that answer. So connect smart enough to accept exponentials or exponents, and so what we have here is a very small number. This is 0.000084207. So the probability you're going to win the lottery by randomly selecting these 5 numbers is very small. So that's problem number 20, and hopefully it helps you understand that the lottery is maybe good for entertainment, but it's not very good for investment strategy. So we'll see you in the next video.